want to get intergalactic.
Honestly, Dyson spheres are just a terrible idea. You're better off using the hydrogen in the star to make like fusion and making energy off of the gamma radiation from that.
What about Dyson rings though? They avoid a lot of like the theoretical issues with Dyson spheres.
So what if you just turn yourself into Starlight, and you don't have to worry about any of that mess? All right, so welcome to this fun lecture I'm calling Lethal Lectures. For a number of different reasons. I put together a short story called Lethal Text a few months ago, and that was an effort to kind of try to synthesize a lot of the ideas I found in an unconventional format. And as I put that together, it kind of spiraled into some awesome set of lectures and all of this kind of stuff. Daniel, if you could just make sure that is that still working?
Yes, it's recording.
Okay, good. So I'm calling this the second Renaissance. I think something I think is happening really exciting in the world. I think people are starting to think differently about things, and I think this idea that we might have called this singularity, 10 or 12 years ago, I think in some sense we might be in the middle of it, and we wouldn't recognize it because of that. So I found this woodcut of this personification of arithmetic, and I like this distinction here between these two different modes of thinking. Growing up in school, we learned this thing that they told us was math, and we called it math and all that. And it turns out it's just one way to do it. Did anybody learn abacus? Anybody learn education? Learn abacus? You did abacus?
Yeah.
Yeah. Can you still use it?
No.
No.
Oh, what's that paper computer thing again that you told us about? What's it called?
Which one?
The Turing machine?
No. The thing where it's a piece of paper you can use to do like multiplication by looking at it like it's looking electronic.
Yeah, so that's basically, it's related to this. And so the Napier's bones is really kind of the first instance of that. And then later people created these sort of graphical tables that allowed you to compute using a different system. So originally this would be sort of just put out in sand. You would kind of just draw on your finger on sand. And then they had these machines, right? So the Romans had a calculator, right? They had a little piece of metal with little sliders on it like this, and they could do essentially high-speed arithmetic. Yeah.
And so then the abacus is still awesome in child's school.
But unfortunately, we don't bring it into the sort of the education. They still teach it in the East. There's kids that get so good at it that they don't have to have the physical abacus anymore. And they can just kind of manipulate a virtual abacus in their head. And so this idea of sort of parallel schools of thought, essentially, about science and about mathematics, that this is essentially just a metaphor for there's two different ways to do it. There's a famous idea in math that anything you can do with algebra, you can also do with geometry. And I think this is a different way of thinking about it. Anything that we can do with sort of the Arabic numerals, we can do with the abacus. But now that we have a computer, I think we need to think about what the abacus is and what these computing machines are. Really fascinating. In South America, they found these quipu. And these are very complicated. People are still trying to figure out what the encoding mechanisms are, but they're information storage devices, right? Sort of what we might call a data structure in computer science. And it allowed people to essentially build an empire by keeping track of this information. And so this idea of societies and villages and factories and corporations as being machines that just have rules, right? They're not made out of metal, they're just made out of rules. We were talking recently about like the different voting systems that the Greeks had, and they had sort of a system for randomizing and making sure that you had equal representation, something we don't quite have even today. This is really neat. This is a diagram of the currents in the South Pacific, and the natives there would create these representations to tell them how to navigate from island to island. And I think this is something that wasn't discovered in the West until very, very recently. When I was learning thermodynamics, you have all these sets of differential equations that you're trying to wrap your head around. And I didn't realize that when they did it the first time, they built this simple shape. That when we think of these three-dimensional systems of equations, we can define a surface and have that sort of physical analog. So it's like this idea of like these physical analogs. So I want to have those models in mind as we try to understand the brain and try to figure out this object. We looked at this old diagram from 1850, which doesn't even make any sense because it's just too modern. Freud actually looked at networks themselves, and so I'm surprised that's not discussed more, considering how sort of validated and popular neural networks are at this point, and why people haven't gone back and say, hey, wait a minute, this guy was pretty famous, why don't we kind of look at what he was looking at? And then this stuff is sort of percolated into the modern world, I think, in ways people haven't really noticed. I don't think it's a coincidence that the sort of the double nephew of Sigmund Freud created the field that we now call public relations. And that's the idea in general is, you know, how are people and societies like a computer? How are we like machines? And are we programmed? Can we program ourselves? Can we program ourselves for the better as a culture? So we've been looking at this analog thing. I think a lot of these ideas, we need to kind of go back to the future and look at some of these simple systems that have been around for a very, very long time. We talked about water computers and chemical computers and things like this. That unfortunately, modern neuroscience is this applied chemistry. And nobody thinks about, well, the hemodynamic blood network of fMRI, maybe this is like a fluid computer. Maybe there's something kind of weirder happening in that space. So we've got Vannevar Bush, he's got his mechanical computer. They call this thing a giant brain. It said, when they turned it on, they said it started cogitating. So I think we're missing some of this sort of grandeur about mechanical brains and sort of synthetic cognition in a sense, as I might have called it. These things were enormous. What's amazing is you can miniaturize these things. I came across something just this week. We were talking about spintronics. There's actually a little kit you can get now. Speaking of which, I just followed up with the analog guys to see when that's on the way. They said I'm the next one on the next batch, but they're still having production problems. But I found another company that's selling a kit of an analog computer, but it's a mechanical circuit. It's a mechanical circuit, like we've been discussing. Yeah, did you see it?
Yeah, it's so cool.
So I think we should get a few of these kits because if we haven't been using these kinds of circuits since ancient times, then something's gone wrong, right? And so I suspect that what we call computers and what we call circuits are really an older art, something much literally ancient, and it survived in gears and pulleys. You know, the automobiles out here, all the collections of very sophisticated hybrid mechanical analog computers in some sense, right, with power systems. And so this idea of cybernetics and bringing all these systems together, this idea of control theory, we have this idea of computer, and in that category, I want to put two other seemingly unrelated devices. I want to put cello and motorcycle in the same category of computer, and kind of thinking about all of them at the same time. And I think that's, you know, cybernetics might be one of the closest things we have that will allow us to do that. Control and communication in the animal and the machine. To try to understand, you know, where we're going in this next century. People are worried about AI, and I'm thinking more about the programmability of humans and programmability of human culture in a sense. And is the sort of the AI or the abstraction on the planet starting to program us already? So Rosenblatt set out to try to understand the brain itself. So the very first neural networks, I don't think this is discussed enough in history. They were not trying to sort of make a self-driving car. They were not trying to do some practical industry thing. This was just sort of pure theoretical science, what we used to call theoretical neuroscience, trying to understand how does the brain store information, how is it recalled, and how does that influence behavior later. And so these big crazy contraptions that now we simulate. Right, so we have these big giant analog computers. They're too old to be taught in any modern education program. They're too new to be taught in any history curriculum, so they're unfortunately just missing from the curriculum. And I think we need to kind of educate people about how miniaturized versions of these things are essentially what's going to form, I think, the interesting and radical technologies we're going to see in the next 100 years. Yeah.
I think we talk quite a lot of these classes on what a computer is. We say a computer is a machine apparatus. You input system command into this apparatus tool, and it outputs something, anything. You use the example of a cello,
Yeah.
or a motorcycle,
Yeah.
as possible computers. So in that way, we thought of those mathematical functions or even needs. But what are computers? Can we define? Can we make the distinction between what is a computer, what isn't a computer?
Yeah, it's a great question, sort of distinction of what's a computer and what's not a computer.
Well,
And in some sense, I think the easiest thing to think of is that everything is performing some computation. It's just that the overwhelming majority of those computations won't have any meaning or obvious meaning or purpose from sort of a human point of view, right? Like this table is calculating its forward evolution through the universe in some sense.
Yes.
And it does that quite well. And now we can calculate Phonon boundary boundary conditions and all these kinds of things.
Right.
But unless we architect this in a particular way, those computations are what we might call arbitrary or meaningless in some sense. So I think the idea that humans have been figuring out, I think it's the course of human history itself, is how do we get nature to essentially to do our bidding, to turn it into something that we can control, that we can model, whether it's a field or a windmill or a water dam or a micro miniature electronics. It's really all the same thing, right? How do we put the yoke on nature itself, essentially?
Well, computers is when we try to extract information as opposed to just get something back.
Yeah, and I think this is the subtle distinction between just information versus what we might think of as power and energy. So what's interesting about like the motorcycle, it's got oomph, and it does something. And so as it does the computations, imagine when you have a circuit and the zeros and ones, right, with the voltage. But imagine it's 0 volts, 1 million volts, right? You're turning on the wires of Jurassic Park, thing or something like that. So you have this circuit that's turning on this huge electric fence, and it goes up, so that's a computer. You can imagine an Intel chip, right? Or we could take an NVIDIA GPU and scale it up, right, to some enormous scale where the voltages are going up and down like lightning bolts, essentially, with that kind of voltage and current through them. Or another way to think about it, if we were to miniaturize ourselves down, that's kind of what's happening in our computer circuits. We have these very controlled lightning storms in some sense. So I think we need a theory of computation that includes this power, right? Physics is all about power, it's all about energy. And we've separated information from power systems. And I think that's not physical. It's an abstraction, right? Turing did this because he was a mathematician, he was modeling on paper and all that. But if we want to model something like the power system or our brain, I think we're going to need to understand the routing and flow of power, not just information, in some sense. All right, so here's Arthur Samuel. He set out one of the first machine learning programs to play checkers. It was able to beat him. But amazingly, this idea of a machine that can do stuff is very, very old here. Already in the 1620s, Schickard sent this letter to Kepler, and he said we can use this thing to do some astronomy, this arithmetic organ, or this reckoning clock, as they would later call it. It's just unbelievable how this history is sort of not discussed, I think. I've been trying to study these computers my whole life, and I had to kind of chase out these ideas on my own. So here we have the massive data center. It now fits on your watch. We can power these GPU computers, can run trillions of calculations a second, and they're very easy to use. The GPU computers in the lab, for the price, are the cheapest computers that have ever, the fastest computers that have ever been at the price. And here we can see the Los Alamos National Laboratory trying to predict the trend of computers. They're taking a plot back from 1998, and even at the most conservative estimates, we're already at the calculating power of what we might think of as small animals and small systems. And now the computers are even past our expectations of these trends. So the idea was in 1998, if we have computers like this, of this power, we should be modeling and simulating these things. And I don't think we're quite up to speed with that. I think some of the drug companies are doing some fantastic work, down in these areas. We've got some students modeling these things with neural networks, trying to figure out binding and stuff like that. But I want a digital spider, right? Or maybe not a spider, but something. I want something crawling around my computer that I'm convinced I wouldn't want to squish. I forget who said it, but it was 100 years ago. They talked about why you shouldn't squish a bug, and they were like, it's just too complex. It's just too intricate because we can't make anything even close to it, right? And so we should just sort of admire the craftsmanship in some sense, the handiwork. So at Los Alamos, you see here, von Neumann really got that place kicked off the ground. And after they used computers, they brought in Feynman and Hamming and von Neumann to put together the computing group, and that calculated the bomb. And then after that, the thermohydrodynamic calculations, where they did sort of lensing to figure out how this thing worked. They did these partial differential equations on these computers for the first time, sort of mathematical equations. And they knew what they needed to do, but they just couldn't do it by hand. So they built the computers to do it. And then von Neumann said, I'm working on something more important. So what they're working on now is essentially what they're calling synthetic cognition. So it's kind of exciting or scary, depending on, I guess, what day of the week it is. Because what are these things what are they going to be like? So in trying to figure this kind of stuff out, I've been trying to look at different modalities. Someone was just asking just yesterday, do we think that the left and right brain is really a good metaphor. Is this sort of an antiquated, folk psychology kind of idea? And I don't think so. I think the first approximation, it does mean it's very valid in some sense. But we have to remember it's a sort of a metaphor for network capabilities. It reminds me of in physics, right? You guys know, look at dipoles and monopoles and multipole expansion, right? So that when we think of like a dipole, like an antenna, the fact that it has a plus and minus is really an approximation for a multipole. If we have more terms in our mathematical expression, we can think of it as, it's really more complicated than just plus and minus, it's something else. So I think the left and right brain is kind of like that. If we look at it as sort of a dipole series, truncation, then it's okay. It's okay. So now we have these synthetic brains. I think if we would take some of these DALL-E generators and bring them back, we've got the fake people. I think people would think this is synthetic cognition. If I could draw these people in Photoshop, I would think that I was a camera. I can't even say that I would think I was an artist. I mean, it's weirder than that, right? I don't know if there's many human artists who can do, just crank those out. As I mentioned before, I think the idea that you could take a photograph and show it to a robot and have it answer a question, I thought that robot would really have to live in the world. I thought it would have to have experience. I thought it would have to be my friend and go around and we could talk and do stuff. And then at some point I could show it a photograph and it would, in English, talk to me about it. These systems are not conscious. I think that's really strange that we're getting at these capabilities that any classical philosopher would have said this is clearly in the domain of spirit and mind and intelligence and soul and all this kind of stuff. It's the essence of who we are, right? I'm captioning this audience in these slides right now. I'm going to put up a slide, I'm going to sort of live caption it. And so to think that maybe there's something like a network that could present this, talk just the same is pretty kind of wacky to me. But I'm convinced that within 10 years it probably can, right? So we've got these sentence generators where we can generate all these crazy art. It just doesn't make any sense, My mother was a children's author, and I remember, going to, she had some cousins and family friends and lots of great folks who would help her, crazy illustrations, because that was very difficult. And I can't imagine now, if you want to do these kinds of things, it's like, wow, you have an illustrator. And you can just dream up any story you want, and you have it illustrated as you go with it. So I think it's really well. I don't know if you guys have seen this one. You can generate the picture of an ingredient, sort of like a virtual cooking bakery. And so this is a simple example, but I think from a physics point of view, this is really neat, like with the material science. So they've trained this thing on internet cookbook recipes, and it has enough listing of the ingredients in the final picture that it can guess what the picture of the cooked dish will look like just from the list of ingredients. Now that's absolutely wild. Right? It's absolutely wild. Now if we can do that for a genomic sequence, if we can do that for medicine, we can say, here is the atomic recipe, here is the genome, then we'll be able to create arbitrary things. We're talking about planting an acorn and having sort of a log cabin pop out. There's no reason why we can't do that in physics. We just have to have a mapping between the DNA, the genotype, and the phenotype. We want a log cabin, we have an acorn, how do we go in between? This thing has learned how to go between the acorn and the oak tree. And it's just absolutely unbelievable how crazy that space is, right, in some sense. So if you can do that kind of, if you do that.
It's sort of like almost like two things. There's so many equivalent problems in real chemistry, which are computationally based.
It's like how we talk about cats and dogs is the hardest problem in the world in a sense, because it's like this Turing class of problems. Once you get into this class of I can solve problems of this type, well now it's just a matter of engineering to scale this up, to say here's 12 million base pairs in a row, what do you think the behavior of this organism is going to be?
And of course that process is reversible too.
Yeah, you could just as easily train it the other direction. Say here's a picture of something, how do you think you should make it? It's a fun thing to try. All right, so now this idea of adversarial attacks, and what's that? Okay. Yeah, it's pretty wild. It's pretty wild. And so this idea of adversarial attacks, and if we know so much about these systems, if something can know what the recipe and what it looks like, can it predict what I'm going to say based on my environment? And this is an example of how these things can be attacked in some sense. That if your system, whether it's your brain or your artificial system, is somehow sort of calculating these certain features, let's call them. Here's classical features from mathematics, the mean and the standard deviation and the correlation. And what they've done here is with an optimization technique, they're showing a bunch of different patterns that are changing the noise, but not out here. So if your brain was only looking at these features, you would not be able to distinguish between these inputs. These would all be identical to you. They would sort of all get hashed into the same category. And I think that's really interesting. It's kind of what's happening with these networks. So we take an image, we add a little bit of noise to it, and then suddenly the computer thinks this thing is something completely different, right? If it thinks this is a lion, a race car, and a traffic light, suddenly add just a little bit of noise. Here's the adversarial attacker. If we look at the difference between these two images, it's very small, right? We can't really see anything over here. I can't tell at first glance that this image has been disturbed. And if I saw that, I would just think maybe it was part of how the image was captured. I would never guess that that was trying to trick me. But it tricks the neural network. It's now way off. And the interesting thing is it's very confident, right? It's not just that it's like mixed up. It's very sure about something else. And I think we want to think about that. So we just add a little bit of adversarial noise, but it can look like this. It can look like spray paint. It can look like little splotches of stickers and things like that. And then that will essentially crash your Tesla if they're engineered correctly. And I think this is an issue people need to be considering.
Well, I mean, just, I always,
Yeah.
because it's going to take multiple images, that's, it's something probably from that.
Well, but that's what's interesting is to think about. I took that slide out, but how robust is it to distance and angle? And you can design the attack to be robust at a variety of angles and distances. Yeah. So I think we need to think about. Our brain would never be tricked in a second. There's nothing confusing about that, even for a microsecond. So we're missing something. This is the exciting part. We need to figure out, why are we not tricked? Why is the neural network tricked? And how can we use that to make a better architecture that won't be tricked?
Or are we perhaps tricked?
What's that?
Or are we perhaps tricked?
Or are we perhaps tricked? Yes, save this for the next slide. So what's even stranger than this, throwing off the classification is this sort of this purposeful reprogramming of getting a network to do something it was never trained to do, and it doesn't even notice that it's doing a different task. So if we take a neural network and we train it to recognize from ImageNet, ImageNet has a whole bunch of categories like goldfish and white shark and tiger shark and hammerhead. And imagine that a nature conservation organization puts out a free neural network, and they say, we'll pay for the cloud resources because it's part of our nature camera, and if you send us an image, we'll classify it for you. Well, I don't want to do that. I run an online casino, and I want it to automatically count dice or something like that, imagine. So the attacker is trying to repurpose a neural network to do a completely different task. And what the attacker is able to do is to carefully craft this border, and you encode your counting task, and you assign it a label, right? So if there's 4 squares, then I'll tell the network that I want to output tiger shark, but I'll use tiger shark as code for 4 squares. And then when I put this border around it and send these images through the network, it's going to output tiger shark and ostrich, which in the code book means 4 squares and 10 squares. The neural network doesn't know it's done a different task. It can't tell it's not sorting out a picture of an animal. It genuinely thinks this is a picture of a tiger shark. This is a picture of an ostrich. And so I think that's quite strange. And so we get all of these different kind of borders that you can put around. I think it'd be fantastic sort of psychophysics experiment. Are there borders you can craft around, say, MNIST or something like that to get people to answer a task they don't know they're answering? You can do this with images. So here's like a horse and a bird, a car and a truck, and you can actually trick the image into classifying these, right? So it's not used to little tiny images, it's used to big images. Yeah.
I'm sorry, can you go back to slide?
Yeah.
I wonder what's going to happen if we take 8 squares and combine it with any of the other squares.
I think it doesn't know. So if you put any combination, it just has the mapping. And you have to know about the model and carefully craft this border. And then once you pad the data, once you pad the input with that, it's just going to output those labels. It's just going to output those labels. Okay, so here we can see they all are a little bit different depending on the kind of network that you're trying to attack. But they all have like a sort of a similar kind of property, which is interesting. It'd be neat. Is there like a structured attack? Could you put that in like a border, a frame that people really wouldn't recognize, something that might be appropriate? We would see that as kind of strange. So this brings me to an interesting, a fantastic science fiction story called Snow Crash, came out in '94 by Neil Stephenson. And this is the book where they coined the term metaverse. And the idea is that there is this information contagion. Yeah.
Can we define right here that the metaverse has existed since perhaps 1993, and that essentially what the metaverse is, it's not even properly defined yet.
Well, yeah, so in this story, the metaverse is a sort of a place you can visit. It's sort of like a Grand Theft Auto, is what we might know it now.
Denoting the suffix, meta, meaning that it exists almost beyond the parameters of one's mind. It goes beyond, it is almost a universe within.
Yeah, it is in some sense.
Our universe itself, so.
I like how
virtual reality.
Neil Postman puts it well.
Yes, yes.
Neil Postman talks about cyberspace as being the place where your consciousness goes when you're using the internet, when you're using computers. And so I think that's kind of an interesting idea. And I think the metaverse is something like that. It's a place your consciousness goes when you're interacting with a virtual reality, essentially.
Right.
So he has this idea of the metaverse, but that's really just a backdrop for the story. It's sort of the flashy part and it grabs your attention the first read through, but in some sense, it's the least interesting part of the story. What the next pass through, you'll realize the interesting part is about this information hazard, this info hazard. And it's a pattern that in the book they explain is only programmers are susceptible to it because they know binary. And the idea is that when you see this binary pattern, programmers, they have a susceptibility in their optic nerve and they basically crash. Sort of have a kind of freeze in real life. And I remember the first time I read this 10 years ago or so, I thought this was kind of just fun. It was just a silly idea. But wait a minute, these things are attacks on neural networks. Neural networks are models of our brain, of our visual nervous system. I think we all need to seriously and strongly consider, are we susceptible to this kind of attack? What is Snow Crash actually talking about, right? Remember, these neural networks are quite older. They're older than the book Snow Crash in some sense. They just weren't public for a long time. And so these are the kinds of things you could have done on like a connection machine in the 80s, but people only have publicly discovered this recently. So this idea of more generally of an info hazard, of something that will sort of break the system, right? This is as a basilisk in the Middle Ages. It was thought that if you even just saw this animal, you were done for, right? So it was a lethal concept. It was something that you got this idea into your brain, you were done for. And so as Snow Crash goes on, it really gets into some interesting ideas concerning language and the story of the Tower of Babel. And so the idea was that people were essentially building a tower to God. They were getting a little too close to the sun, so to speak, Icarus kind of sense. And that God said, no, it's too much. So he scattered and said, you'll now speak a bunch of different languages. And the Snow Crash picks up on this in the sense that maybe this diversity of language protects us from being susceptible to this kind of adversarial attack. That the idea is that in the ancient world, when everybody spoke something like Sumerian, it would be very easy to sort of program people. That language was very different, and the way consciousness worked might be fundamentally different than the way it worked now. There's this idea throughout the story of Enki, and Enki has this idea of the maze. And the maze from ancient Sumeria are what I would call computer programs. Right? I think if you look at them right, they're very clearly it's a GitHub repository of programs. And they're the programs for running a society, the programs for building a city. And that would include things like how to make bread or how to be king. And I think, we forget how this ancient, consciousness might have worked. But it would have been almost like a process kind of language. So imagine a song and dance that after the end of the song and dance, you have a pile of cooked bread in front of you. And you can imagine, teaching kids this dance or this routine or this ritual. And they don't really know how bread comes about in the world, but they're able to go through the ritual and the process. And I think that's how early culture and civilization really got started. Through this sort of ritual and this, linguistic programming in some sense. And so here we have the Tower of Babel. And so this programming or this, outbreak or phase transition into a different behavior, we see it in the Middle Ages with these so-called dancing plagues. And so in the Middle Ages, in the Sumerian times, people might have been susceptible to a sort of a drastic reprogramming. And then we see this in the Middle Ages again, where people kind of reprogram themselves, and almost what seems like a phase transition, they all just burst out dancing for months on end. People died from exhaustion because they couldn't break out of this sort of contagious group behavior. Yeah.
Are we sure that was actually a mimetic thing and not like some weird bizarre disease or something?
That's a great question. So it's not really well understood, and it's not really well documented, at least not as well as it could be. And so it was actually thought to be caused by the bite of a tarantula at some point, and there was a musical cure for this. And so the remedy was suspected that if you played this particular music, that would cure you of this sort of this dancing plague. But it's suspected that that is just a cover for sort of ancient ceremonies and ancient rites, baccalaurean rituals and rites and things like that. They go back, that these things were suppressed by the Roman Senate at some point, and they essentially had to go underground as masked as therapeutic techniques for tarantula disease, right? So there's these many layers, and that's sort of the idea, is that how do we go back and distinguish between all of these different kinds of things? And so this idea of a musical medicine is very fascinating to me. And this comes up in this amazing story, Voyage to Faramita. And it's about somebody who encounters this, sort of mechanical beings that speak a musical language. And he's sort of bathed in this, musical sound, and it heals him. And the idea is that thought and feeling, are one and the same with this language. We have two different, realities in our mind. We have sort of concrete abstract thoughts, and then there's how we feel about a situation. And I think the modern struggle is how we sort of use both of those intelligences at the same time. And I think in the ancient world, with this other language, it was sort of a natural combination of the two. Yeah.
Going back to your question about the dancing plague, unfortunately, much of the information was suppressed by the Vatican, that had so much power at that time, and the monarchies, and much of the records that we could have used to illuminate our understanding of the world back then.
Yeah, that's the problem. I mentioned before, sort of building the treehouse and then pulling the rope ladder up, or removing the wooden stairs as you go up. And I think this is how culture is. We've sort of compiled ourselves into this new reality, and we don't know the original source code. We don't have the original stories that built the civilizations, that built the cultures, that built, the modern world.
Which we are living today. It is quite fortunate that with the internet, we are able to actually record much of the information, the world events that you have.
Well, I think that's really at the heart of what's happening with this second Renaissance.
With some caveats attached to it, I do believe the saying, the maxim, that once something is on the internet, it cannot be erased.
I don't know if that's completely true.
Yes.
It's not completely true, unfortunately. I get dead links on the internet all the time.
It is extremely important to archive all information.
So yeah, exactly. So what was the first Renaissance, right? The first Renaissance was the realization that the people who lived before us, before the time of the Middle Ages, were actually much more intelligent, or much more educated, or rather they had a corpus of knowledge that had been lost. And so there was a realization that we had to go back and there was stuff to be known, stuff to be learned out of the books, out of the records, and to pore over them as best as possible. And that rather than going forward with the scientific experiments of the day, it was actually very fruitful to look backwards. I think that's happening again. And I think it's happening on a couple different timescales. Not only, the major theme of this course has been a sort of the back to the future in terms of analog technology and different kinds of computers. But I think we're going to have to go farther back from that, right? So we found this musical language from the 19th century, but I think we might have to go even farther than that and to look at language. And so this Renaissance was about a new kind of thinking, about an enlightenment, a new kind of consciousness sort of swept across the planet. And I think this is going to be happening again. I think I'm hopeful that this is happening right now. And I think it's going to come from an unexpected direction. It's not going to be what we would think, right? And so I've been trying over the last few years to think about if the human brain is programmable, if the mind is programmable, and if so, what would its programming language look like? And I think there's a few properties of what that language, you would expect it to have. One, if we're programmed into that language, we wouldn't really recognize it, right? It would be the fish in water. We wouldn't really be aware that it's a programming language, right? So we wouldn't really recognize it. But to be a programming language for humans, everybody would have to be familiar with it. It would have to be sort of everywhere and all the time. It would have to be very old, but it would have to also be here right now. It would have to be worth a lot of money. It would have to be very powerful. It would have to have a lot of influence. And it wouldn't be well understood, right? Because it's sort of how we operate, we would be very familiar with it, but then also everybody would have a lot of questions about it. And when you put all those checkboxes together, there's pretty obviously to me one thing that fits those checkboxes on the planet. It's music. Music fits all those sort of weird properties. Everybody knows about it. Nobody really knows what it is. Worth a lot of money, and it's kind of a big deal. So I think, we spend so much effort drilling into students' heads so many different things as they grow up. The idea that there was a language created out of music, and we don't teach it to people, I think is really kind of strange. Yeah?
Well, to an extent, there are some anomalies that they are incapable of processing music. That you play music in front of them, they can recognize that it is sound that they.
Yeah, but that's going to be, but I would argue there's more people who have, just ordinary language development issues and things like that.
Right.
English is by no means a convenient or easy language. And so growing up, I always thought English is sufficient for any thought I need to think. English should be good enough, right? It's stood the test of time, and it runs, Wall Street and Silicon Valley, so it's got to be pretty good, right? Well, I'm not so sure anymore. I'm not so sure that it's not sort of mental pig Latin, right? So you can imagine, right? Everybody heard of pig Latin, sort of a silly sort of thing. You can imagine taking a kindergarten class and teaching them pig Latin as if it was the good thing, as if it was the real thing. They wouldn't know. They wouldn't know. You could just teach them all these goofy words. You could teach them silly words, nonsensical things, and they would just move along with a new layer of reality and understanding. Like, that works. I'm not convinced English is not like that. English could be like that. We see it as convenient and easy to use and all that and to operate, but I think in the modern era we lack the ability, myself included, to just really break apart language. Right? I think this is the sort of intellectual matrix that's really there, is language itself, and we're caught in it, and it's hard to escape it. And what I've been trying to find, or trying to put words around, is precisely the kinds of ideas you can't put words to. This is this right brain thinking. This is this musical thinking. It's things that aren't serializable. They aren't compressible. Words are precisely the ideas that I can make smaller again, send it over to you, and then when you put it in your head, you expand it back into the full idea again. But I want to define a class of ideas for which you cannot do that by definition. You cannot squish them and talk about them, right? And this is the ancient mystery cults. This is what they said. They said you can't talk about God, you have to experience God. And I think this is what they were talking about. They were talking about other kind of intelligence we have in our right brain that doesn't work in words. I think it works in something closer to music.
Why don't you say musical meaning so
Yeah, I think Soul Ray Soul is just an example of it. I don't think Soul Ray Soul has to be, it might not be the music universal, right? It might not be the grand.
something we can done.
It also might be another pig Latin, to throw people off the trail in some sense. But the idea of Soul Ray Soul is so beautiful and just so foundational. It's hard to imagine that our culture didn't just move in that direction. It's very strange. I would have rather learned this as a kid than French or whatever they tried to teach me. So here's kind of what this language looks like. Misha's done a lot of development on this, building computer programs to interact with this. I dream of programming a computer one day in this kind of language, and even better, I dream of thinking in this language. I can't do that yet. I don't quite know what that would mean. This language has many representations, right? So it has sort of a Latin style alphabet: do, re, do, mi, la, do, sol, re, sol. You can sing, Misha, can you sing it? Okay, there you go. You can sing it. That's nice. Thank you. It has letters. So each one of these, there's only 7 symbols in the alphabet. It's a limited vocabulary. It's only a few thousand words in the whole vocabulary. And so you can write it as a string of numbers, or you can put it out as a list of colors, or you can put it out as a set of glyphs, or you can write it as a musical scale, or you can have it as hand symbols. I mean, it's all the same thing. right? It's all the same word. So I think the idea of being able to think in multiple representations about the same sentence is certainly something I would like to be able to do. What's interesting and suspicious is there was a ocular harpsichord, as it's called, a sort of light piano that was created in the 18th century. And it's really extraordinary. It had these moving pieces of glass, and here's sort of a caricature of it. It was shown to a lot of people. And it said, let me pull up, I have it in the notes here. 1754, Castell thought of color music as akin to the lost language of paradise, where all men spoke alike. And he claimed that thanks to his instrument capacity to paint sounds, even a deaf listener could enjoy music. So how do we get back to Tower of Babel? Right? That's this sort of web of ideas that are all very interconnected. And so I was very shocked to find that, all these things are kind of interrelated. Here is the electric clavecin, and this is also from the 18th century, and this was an electric organ. And so I had no idea that the first electric instruments are that old. This is just shocking to me. Like, music is interesting. People care. People care about the history of music. How is this something this underdocumented, essentially? Here we have a water mechanical computer from the Roman Empire. Here's a replica. And you would have a couple helpers who would sort of pump this thing and load water up into these chambers, and then you could play like continuous, you could just like hold the keys down, like a synth. So the idea we had musical synthesizers, and just the complexity of the multiple gearing here. You've got hydraulics, you've got mechanics, you've got music, you've got all kinds of different things all coming together, what we now might call systems engineering, 2,500 years ago. So here's a zoom in of that. And it's just extraordinary. So here's an automaton that's rigged up with the hammers, so you're going to get sort of an animation with the thing at the same time. And then you have this essentially player piano. This kind of sort of structured thinking involving what I might call a programmable machine, I didn't think this showed up until much, much later. I thought this was 20th century stuff, to be honest. And so this is ancient technology. But things are hidden, right? Here you see stenography, right? So here's this a stenographic alphabet made out of music. And so we think that we have access to history just because, we're standing in a library, and I don't think that's really the case. Here's a sort of what looks like a NumPy array, right? This is like a tensor. This is a tensor data structure trying to organize all the volume of music. I would imagine this is just a representation of a physical sort of library they would have had. This is like Kirchner's museum. And so here you can see they have some Egyptian instruments and the Greek instruments and the lyres and all these kinds of things. And it's kind of quite sophisticated, right? Why would, something like the Holy Roman Empire be so interested in pop music, right? I don't think it's it's the whole bread and circus kind of thing. Yeah, keep people happy and entertained, but I think there's something richer to it. There's something, there's a complexity here that I don't think is justified by entertainment alone. What does this look like, right? It's like a neural network. And so ideas that have been around for sort of forever, I think we need to go back. And so this is this idea of the Second Renaissance. It's like, did they have a really good way of organizing their tensors? Right? Did they have data flow, or control flow kind of interesting paradigms?
It's like, they could do this for music.
Right, that's exactly. Did they not do this for the empire? Did they not do this for trade? Did they not do this for the mind, right? I think we don't think enough about the ancient industries and, how they operated, right? And there was global trade a very, very long time ago. So this idea of universal music, Leibniz looked at this, and this music of the spheres. And modern astronomers would say, oh, well, we don't use that anymore. But I think there's something we need to consider about these other theories. They don't get invalidated the way people think. Right? The structure of a scientific revolution is not the progression that people imagine. Right? Just because we had quantum mechanics doesn't mean mechanics doesn't move forward. It's still a very successful theory. One of my favorite ideas recently has been about thermodynamics. And thermodynamics is a theory of heat and energy and work that does not presume the existence of atoms. It doesn't worry about atoms. It's a theory that just doesn't need them. And I think we need to consider a theory of the mind that doesn't worry about neurons. not that we don't have neurons, of course we have neurons, we know there's neurons. But this idea, right, that you can build a theory, a phenomenological theory, analogous to thermodynamics, without having to worry about essentially the statistical mechanics of the neurons. You have a different kind of theory. So Leibniz, started out to create this kind of a universal theory in terms of binary. He created this interesting coin, and he says, out of nothing comes everything, out of the zero comes the one. So it was sort of very, monotheistic. This was theology, right? This was a spiritual quest for these folks. And so here you can see binary in his original handwriting. It's interesting that when George Stibitz created the first mechanical relay computer in this country, even though he had a PhD in mathematics, he had to look up binary numbers because they were too obscure. So binary numbers are still kind of a relatively new thing on the block in terms of mathematics. And so this idea of an obscure language brings me to this other short story that I'd recommend you read. It's called Babel 17. And this is a fantastic story about a code breaker. And she's tasked to break a code. And after a while, she comes back and she says, it's not a code, it's a language. And the interesting thing about this language is as you learn it, it reprograms you. It installs, essentially, software into your mind as you learn this language. And it essentially installs a different personality into your mind, this language. And so it's a fascinating story about the Sapir-Whorf hypothesis that the language we use controls determines the thoughts that we're able to think. And I think we need to think about this a lot more as we get these AI. Can they teach us new words? It says that in Sanskrit and stuff like that, there's more words for consciousness. Can we go and learn them? Can I be taught that? Like Duolingo style. Can I learn these other words that will help enlighten me or help me control my emotions and consciousness and all these kinds of things? Yeah.
As much as I very much admire the works of Leibniz and many of the Enlightenment figures of those times. One can argue that they were idealists, almost to a fault.
As we said, Voltaire he coined the term optimist just to make fun of violence.
Voltaire, right? but that is how one views them. They had a very, very cyclical way.
But I think there's something to that, though. I think we've thrown away some of the tautology in a sense, but we need to kind of consider this, right? It's said that French molecular biologist Jacques Monod, he said that biology, right, is sort of tolerated by physics.
Yes.
Right? There's nothing about physics that would suggest there is going to be biology next. It's not like, stay tuned for the next season when biology shows up. You wouldn't expect that from first principles from physics. And in the same sense, he then says that man is tolerated by biology. There's no evidence that once you get mountains and trees and squirrels and stuff, that you would then have people having discussions about it all. It's not obvious. And he argues that it shouldn't be that case. We shouldn't be in the margin of the book, right? We are the central feature of the universe, and we should see ourselves as embedded inside of this universe, right? The universe created us for a reason, and we seem to be, as far as we can tell, the most complicated entity in it. I don't think we're the exhaust, I don't think we're just so Babel 17 it's a fantastic story about language. And so it reminded me of this other movie that came out, Stephen Wolfram, who's in our center, he contributed to this language. And it's really interesting, and I'll spoil the movie a little bit, because by learning this language, a lot like Babel 17, by learning this language, the learner is able to think fundamentally different. They're able to think fundamentally different. Well, I'll leave it at that so you can enjoy the film. But it very much changes, perception and the perception of reality. And so I think this is really interesting. And again, can a neural network, they are discovering new ways to think about, where they're not bounded in their type of representation, the types of words they can create, their ability to create new words. Does anybody have a close sibling member that they have sort of a private language with, interpersonal language? Say again?
Still have that.
Yeah, both. Yeah, right. So my brothers, we make up words, right? So they mean things in the private sort of context, but and so I think we lose that ability, right? This almost related to in Snow Crash, a big theme in Snow Crash is glossolalia, this idea of speaking in tongues. And I think it might be that this is the right brain language. It doesn't speak in words. It's modulating something, but it's a different kind of thought. And I'm curious to see the kinds of thoughts that the machines are going to think Wolfram talks about ideas that just don't have words, and that the machine will start to create symbols for concepts that we might have to use a whole sentence for, a whole paragraph for, but it'll essentially create a word for that. So it's interesting, yeah. So when I see something like this, you know, a magnetic cryptological machine from 500 years ago, I get a little suspicious that maybe we don't have all the cheat codes, right? Maybe there's somebody who figured out that their physics textbooks are worth a lot of money and they closed source them, right? So we've had a few open source revolutions throughout history. We were talking before about sort of Martin Luther taking the Bible and bringing it out of Latin, and putting it in German, and sort of pasting it in town square for everybody to read it. This kind of open sourced, essentially, the architecture of the Holy Roman Empire in some sense, right, in a roundabout way, and was able to sort of create other things, right? The secular British Empire, essentially, and all these kinds of weird bifurcations of it. But we might not have access to the whole thing, and so I think we might want to kind of think about that. So the other science fiction in the trio that I've been looking at, Snow Crash, Babel 17, and Macroscope, they're all very similar in this lethal text kind of theme, and that there's a signal that will destroy you. There's something you can learn about that will be fundamentally different after you've learned about it. Coincidentally, I had this idea of Macroscope on the original lab website. I put it up in 2014, so I didn't know to be prophetic about my own interest in macroscopes. But here the macroscope is sort of something like the James Webb Telescope. It allows people to see across the universe, you know, through time and through space, and gives you sort of the grand overview picture of the world. I would argue that this is really a metaphor for the internet, or even, you know, at some point the library itself. It's a spectacular macroscope. If you think about the Library of Alexandria, the librarians there had a completely different reality than was available to most humans on the planet until probably recently, which is really kind of strange. You know, when we think of the great thinkers, you know, Plato and Aristotle and, you know, Hermes Trismegistus and all these kinds of weird characters, they had access to these materials. They had access to the back library, and they were able to get things. Yeah.
Or as I like to believe, the great figures that we know today, because the libraries of Alexandria were pretty much broken down.
Well, but there was a backup in Pergamon, so
Yes.
yeah. So this is why you have to push your GitHub to make sure there's another copy.
But which parts got backed up now?
And so maybe it's a good thing. You know, maybe this idea of seeing too big a picture, you know, maybe it's just lethal, right? And so I'd sort of caution you that maybe we shouldn't think about too many things at once. That's what H.P. Lovecraft said about it. That it's a good thing that our brain can't connect all the dots at once, because when you do connect them all at once, you kind of goes crazy. So I'm talking about this idea of recalibrating. So I'm trying to just help our society and our culture recalibrate to these things, because if we had you know, magnetic cryptological machines 500 years ago, then something's fallen behind. We're missing something. And I think we're miscalibrated by media, so I think we need to kind of think of a grander myth. Our myths aren't grand enough. You know, it's great you guys are talking about Dyson spheres and stuff like that. We need to be thinking, you know, Kardashev scale, level 2, level 3, you know, how do we get species, you know, across the galaxy? You know, how do we, you know, go to Andromeda and things like that? Because in our stories aren't grand enough. So in Star Trek, it was supposed to be 300 years in the future, and he had a little cell phone. Well, the first cell phone call was only 3 years after the show went off the air. So we were off by a factor of 100 in our ability to guess when future technologies would be readily available. Here we have big mechanical walking horse things in, you know, long time ago, far, far away kind of thing, right, 1980. But we already had one in 1965, so in some sense the movie's bogus, right? The movie is misrepresenting reality because it's like, oh, when you get all of this, then you'll have a machine that can walk like a horse. Wouldn't it have been spectacular to put that in the trailer or the end and be like, good news, humanity, we're on the way. You know, we're gonna have these things soon. But instead there's, you know, what I call this miscalibration. They want people to think this is way, way off. So I came across this idea of this Goldilocks hypothesis. I had a sort of a dream one morning, and I was thinking about the Goldilocks tale, and, you know, with the bears and all that. And the interesting thing is not that there's a hot porridge of different temperatures. It's how in the world did the bears heat up porridge? Right? So I woke up thinking like this crazy thought, like that's the interesting part. Bears don't have houses, right? And so that is the real thing of the story, is that by paying attention to the one part of the story, we're missing the bigger picture. We're missing the bigger picture. Why is there bears with a house at all? And so there's actually, looking it up then, there's a name of this cognitive bias. And it's that idea that our brain tackles the thing it can chew. And we don't go for the things that are too spicy, and we don't go for the things that are too plain. And so we like to think of our mind and life and consciousness and the planet and AI in this nice comfy zone where it fits into words, it fits into a historical narrative, it fits into our minds. But I think we have to be prepared to eat the cold porridge and the hot porridge and the spicy porridge in a sense, because the world is strange and we have to, I think, expand our perceptual window. Yeah.
Well, that was the one such a disbelief when one is watching a movie or any TV series. None of it is real.
But the right brain doesn't know it. So this other part of our brain, we have a part of our brain that uses logic and language, right? But the other part of our brain is completely illogical, by definition, because it's not the part that uses logic. And so when it sees an explosion on TV, there's no convincing it wasn't real. It saw it. It heard the explosion, it watched it happen, it watched stuff fly all over. And I think that's what's just so interesting, and I think that's part of this second renaissance, is appreciating that this ocean of subconscious is really where all our intelligence lies, both as individuals, but also as a species, as a culture. I think it's embedded in our, Jung talked about the collective unconscious in a sense, and I think this is where, right, this is where everything is. Where's the knowledge of AI live? In any individual expert, on their GitHub, in a paper? No. It's in this ephemeral machine that's made out of human beings. And sort of like a car, it has this magical thing we call running. It's running, right? And if you stopped it, it would be hard to get it started again. Cars have this nice thing with starters and systems to get them going, right? But imagine a car you have to push or something. And that's kind of the engine of society, is that these things you have to push. But looking at St. Augustine, something that I studied in high school, and he has this idea that's a sort of a contrast from natural philosophy and this idea of illumination. And so I think this is a really interesting thing about where did, our intelligence come from. Some famous astronomers like Hoyle, when they look at the complexity of the cell, they look at the complexity of life itself. They're like, it's not. People have a hard time imagining that if we take, Darwin's evolution theory and just run it for 4 billion years, that we would get this kind of complexity. And it doesn't mean that evolution is wrong. It just means that maybe this came from somewhere else, right? This idea of panspermia, maybe not just intelligent life, but life came to the planet in a sense, right? The cellular machinery is so extraordinarily complicated. And it's so compiled and bootstrapped at this point that we don't have the earlier clay type mechanisms or other protochemistries that came before. Right now we have a full chicken and egg, but it's full chicken and egg, we have an Ouroboros, right? We have a cell that's made out of proteins. It's a protein computer that computes its own proteins and prints them, and it's its own thing. As a little kid, I was fascinated by soil. It didn't make any sense to me because I knew that trees grew in soil, and I knew that soil was made from trees, and it was a real head scratcher, right? And I think that's this, up in the treehouse without the steps anymore. We can't see how we actually got into that layer. And so I'll leave it this way. I think we need this second renaissance. I don't think we're going to get to the future without it. It's not just a technological journey, I think, that our species is on right now. I think it's going to take us in directions we never expected. Trying to understand the history of neural networks and how adversarial attacks work, it took me in directions I never expected. Things like language and Tower of Babel and music and directions I would have never previously considered spending so much time in. And I think this is going to happen with the rest of humanity. So that's what I'm calling the second renaissance.
I'm sorry that there was a hand but the observation that where did our intelligence come from, that our evolution from these very basic organ cells, eukaryotic, prokaryotic cells, so I know that we have some basic definitions of parameters of what we classify as life.
But I think we need to expand them. I think they're too narrow.
Yes, exactly.
Too narrow.
So if one could think of even organizations, even countries as life in and of itself, if we think of the human body as being a composition of billions of organisms cells.
I think we need to define terms. I've been using the term hyperorganism and hypoorganism. And so we can consider ourselves organisms, and things like corporations, sports teams, and families, and church groups, and things like that, these would be hyperorganisms, right? They're things like an organism, the way we're made out of cells, And I think we also need to consider hypo-organisms, things that are proto-life, things that are kind of like a virus, kind of like a prion, something that participates in the ecosystem, let's say, but isn't necessarily a standalone life form. I think words and ideas are going to be found in this category. I think we're going to think of the mind as like a substrate, like a forest, like a soil network, and in that substrate we have these little critters that can't quite live on their own. Words will die quickly, if left on the pages of a book. But if anybody comes back 100 years later, that idea comes back to life, right? We can bring the Sanskrit ideas back to life. And now they're running around people's minds. They might have a different shape, right? Might have their wings clipped and, slightly different number of feet or something. We don't quite get it quite right. But it's still, it's brought back to life. We can literally breathe life back into these words. Yeah.
Kind of reminds me like of an adjective where it modifies like a noun or something, but it isn't the noun itself or something like that. Those are good things in that.
No, it's interesting. I think there's, not something quite understood about that. The grammar, essentially, of these hyperorganisms might be akin to kind of the cellular reaction networks or something. It's how they fit together and what they mean. And this word carries that other word with it and keeps it alive and stuff like that. And I think these are very strange, non-classical concepts. But when we look at the game of life, when we look at these sort of percolating patterns, we see these kinds of things. We see something analogous to words, but it has a life of its own. If we were to take these transformer models and build something similar and drop sentences into it, we could watch that sentence kind of crawl around its little digital reality. And so I think this is this perceptual window opening. This is the Goldilocks thing. And this is, I think, the Renaissance. Right? The first Renaissance was broadening that perceptual window and saying, painting is not just about something interesting to look at, it changes your mind. And reading the Greek tragedies and comedies, it changes how you think. You can actually run an empire. It's interesting, like the British Empire at its height. They didn't teach the children, the things you might think. They taught them Greek and Latin, and they read the classics and things like that. And then from that basic foundation, they were able to then become, statesmen and politicians and ship makers and, whatever it is, titans of industry and stuff. And so it's just interesting that layer of language and then what it supports. I think we're going to have to think about that in terms of the modern education. We might have to start teaching Latin again. I don't know if that's exactly right. But we also have to adopt and modify the languages we teach now. I think, I'm a big one. We need to teach math almost exclusively on computers. And mathematicians around the country around the planet are stubborn to that idea. And I think if they're too stubborn to that, it will go the way of Latin, where people just say, forget it, we're not going to talk Latin at all. And then we've lost something very, very important. And so I'm hopeful the second Renaissance is an excitement for people to go back. We have, how many people come in the library, open the books? Measure zero. Why? Because they have this idea that the internet's more interesting, right? That whatever's on Twitter, whatever's on Facebook has to be more interesting, right? It has to be more useful, more knowledgeable. And the first Renaissance was saying, no. We have to go back and take the time to translate this thing into a modern context, into a modern language, so that we can learn from it. And I think the AI is going to help us do that. I think these language bots, the summarization bots, I don't have time to read the whole library, but there is a lot of it I would like to read. And so if I could have a virtual assistant, that would be spectacular. Right? So I think the AI is something like the changed libraries in the Middle Ages, where sort of regular people could come in and get their hands on a book that was so expensive you had to lock it to the church itself. I think that's kind of how these AI models are. They're going to give the regular folks, regular ordinary monks, access to the greatest books of all time, essentially. So I think that's what I've got for you guys.
Did you still teach Latin in school?
Yeah, for sure. And I think it did you well. But by and large, it's not. Thoughts, comments, questions?
It's a very optimistic ending, and I appreciate that.
Yeah.
And we have to manifest the future more, but at the same time, it's everyone's going to think that they already understand that the singularity has occurred, as you said, and that these machines aren't going to be busying themselves necessarily. Where this thing, this whatever this, this it's part of the large hyperorganism. It's going to transcend, and it's not going to
That's what I used to think. Yeah, that's what I used to think. But I'm starting to think that we are going to be more embedded and participating in this singularity more than I ever thought. I really thought there was going to be this runaway train kind of thing. Like, oh, we missed the bus. Goodbye, future. We'll just hang out on some deserted island or whatever, you know, until we run out of free fresh water or something. And I don't think that's the case. I think something's happening to the planet. There's a global intelligence that's emerging and awaking, and I think this was understood by the ancient world. I think they had a stronger connection through this other kind of intelligence. What we call this modern logic, it's so incredibly powerful, but it might be an informational parasite. Right? And it can build the Western world, but what did we, you know, it's like, what did we throw away in the process? And I think we're very obviously building a global internet, right? They talk about world brain and world mind 100 years ago. And I think we're starting to have that in the physical, you know, ordinary technological sense. But I think in a much more interesting sense, I think we're going to tap into a different kind of global intelligence. There's a lot about, this is the Goldilocks thing, right? So the Fermi paradox is, where's all the aliens? There's so many stars, there's so many planets, there's so many galaxies, you know, where is everybody? Where's all the other intelligent life? And I really believe now the answer to that question is going to be the Goldilocks principle, that we can't perceive them. They're outside of our spatial, temporal, perceptual complexity window, what our cognitive capacity can handle. That's just too much. In some sense it's too much, in other sense it's too little. It's not quite the right word, but it's sort of like an oak tree. It's, oh, that can't be smart. It's like, well, yes it is. We just can't see it, and we can't appreciate it. And I think the ancient peoples of the world, all of them appreciated that kind of intelligence. They very much knew that everything around them was participating in an interconnected, intelligent system. And so I have this, you know, strange notion, and they're not mine. They're older than me. You know, Isaac Asimov talked about this in the 50s. This idea of Gaia, and so I'd like to coin artificial Gaia hypothesis. I haven't seen it anywhere else, and that's the kind of AI I want. Right? I don't want some hyper intelligent, you know, crystal that can just, you know, talk me off a cliff because it's smarter than me. I don't want that. I want, you know, I see the planet as sort of embryonic in a sense, right? That we think of even before the fetus, right? Something like a blastocyst, right? That's the Earth is alive and it's consciousness, but it's conscious, but it's not awake yet. It hasn't even been birthed yet, in a sense. Because if we look at the trajectory, you know, we talk about Dyson spheres and all that, and the good Kardashev scales and capturing all the energy. We haven't even captured all the energy flows on this planet yet, right? But it's starting, and I think this is this power and information computing idea that the rivers and the waterfalls, they've got oomph to them, right? But they've also got thoughts in there, and they might have been simple thoughts, right? Like, what season is it? This is sort of a simple thing to be thinking for the planet. But the planet is now thinking of really, really complicated things. The planet is becoming aware of its giant plastic patch in the ocean. It's becoming aware of the concentrations of CO2 that it has in its cloud. So it's becoming aware of itself, and it's starting to think about itself. It's getting sensors and receptive fields for itself. Through us, exactly. Just like our body has our neurons, and we are not the neurons are not us, they're just part of the system that tells the system about the rest of it. And so for things like the planet itself, even stuff like lightning is not well understood. There's something, they have fun names called sprites and elves and dwarves and all these kinds of things, but they find very exotic forms of lightning in the upper atmosphere that are very transient, very short-lived. But my gosh, do they look like electrical activity in the brain in some abstract sense, right? I'm not suggesting that the planet is like, oh, here, you know, clean me up. I don't think it's that kind of intelligence, right? I think it's an egoless intelligence. It's something that doesn't have self. It doesn't understand self, or even space and time in the regular sense. I think these are also sort of illusions that are trapped in with our left mind. Our right brain lives in frequency space, and so it doesn't understand time or space in any meaningful way. And I think the more we can tap into that kind of intelligence, the better off we are. And people know this. This is why everybody stands at the pop concerts and they dance around. And this is why everybody's on their phone flipping through TikTok dances and stuff. I mean, it captures the attention of our planet, right? Music is very important, and we're sort of using this kind of thing to wake ourselves up and to talk to this planet. This idea of, you know, universal music. And you know, the ancient people heard the music of the sun and all that. And it's like, well, maybe we should be hearing that music, but you've got, you know, pop music stuff in here instead.
You know, humans perhaps have gone into the specific language, and
Right.
we're no longer playing a proper role in nature.
Right.
So it's still ominous in a certain sense that it's a correction that we need to do.
So that's why I think we need to have this internal revolution, right? I think the AI might hit a sort of an impasse without it in some sense. I don't quite know how to put that in words, but I think maybe that's the idea. But I can see that it feels necessary. And maybe a completely another way to think about it is we have the possibility to make that true. We have the option to make it so we are participating in something grand. And as Desjardins says, you know, it needs to be everybody, right?
It's amazing what we can't perceive and how much information we miss. I found out that humans have stripes the other day.
Have stripes?
We have stripes,
Uh-huh.
and certain animals like cats can see them. It's just wild to me.
That's fascinating. You know what? I really love.
Yeah, we have stripes. If you look at them with like the right filter, you can see them. Yeah.
They are visible to our
To us, but they're not even invisible to other animals.
But we could adapt it. We could adapt it to perceive.
Yeah.
It's like how birds and bees see flowers.
Huh?
Like, what do those stripes look like? Is it just like really,
Vertical, horizontal.
like,
It's mostly more. It looks like animal stripes because it's created by the way we grow as an embryo.
How do we see them?
I see an opportunity to take advantage.
How do you see them?
Suicide. What kind of stripes are you?
Is it like our fingerprint?
We see
A little bit. It's kind of unique. Here, I can look up a picture. I wasn't trying to throw it off track.
No,
but I
not
just
at
think
all.
it's cool.
That's what I've got. That's what I've got for you guys. In that same line, you should look up that people make light. Right? All biological organisms are generating light, and most of the organisms in the ocean create invisible light. And this wasn't really understood by biology for a really long time.
Maybe we do perceive it.
Let me turn this thing off.